Here we are doing some examples with electrolytic cells. So these values I copied off of the table of standard reduction potentials. You would be given all of the ones that you need. The nice thing is with the current version of the AP exam, you're given ones specific to the reaction you're looking at. Rather than having a table of 30 you have to sort through, but you do have to be very specific in terms of understanding what can be reduced or what could be oxidized. So in terms of things available to be reduced, the lithium ion could be reduced. Remember, the reactions are written as reductions, or water can be reduced. Both of them require voltage, but water requires less voltage. So this one is the most likely to occur as a reduction. For the oxidation, we do have water, which can be oxidized conveniently into oxygen, requiring 1.23 volts. To get that bromide ion, to oxidize back into bromine, it requires just a little bit less voltage. So this one is more favorable because they're both going to be reversed, and we're subtracting both of these. We want the more negative one. So what will occur is this in terms of my reduction, and then the flipped version of this for my oxidation. An important piece with those is just always double checking that our electrons are also balanced. So we put that all together, and we can know that our electrons are balanced because in addition to balancing my hydrogens, my oxygens, and my bromines, I've got a -2 charge and a -2 charge. I do include the states of matter here, but it's very common that you don't have to require or include those, but it's always good to keep those in mind. So our cathode is the reduction we chose. Our anode is the oxidation we chose. Cathode minus anode, without doing anything special there, shows that it requires not too much voltage, actually, and I did that wrong. So I need to double check that, and by double check, I mean do it right now. That would be 1.09 and 0.83, 1.92 would be the volts that would be required. Very easy mistake there to do a negative and a negative or add things. So remember that we're subtracting because that voltage seemed really small if both of them are requiring voltage. So what are some signs of reactions? We want to be thinking about what's being made. Well, bromine's being made. We might know or might not know, but that is a liquid and it's got a reddish color to it. Hydrogen gas is being made, so we would definitely observe some bubbling. And then if we had some sort of pH indicator, we would also see hydroxide. So that could be something we would see maybe with a phenolphthalein indicator or with a universal indicator. These would be occurring specifically at the cathode and at the anode, but then eventually would mix throughout. Number 2 is a less likely one, but still really tests these. And when I say less likely, it hasn't occurred as much on the exam, but that definitely doesn't mean that it can't occur. So here we're still talking about the pure substances. We don't have any water, but we do have a mixture. So my comment about pure substances was actually a little premature there. But I have sodium as a cation and potassium as a cation. A cation is going to react at the cathode, but which is more favorable? From the table of reduction potentials, potassium slightly more favorable than the sodium. I have iodide and I have chlorine. The iodide is quite a bit more favorable than trying to oxidize the chlorine because once again, both of these are the reductions. Chlorine really wants to be reduced. Iodide wants to be reduced a little bit less. This is the first case where we do have to balance our electrons by looking at the charges here. And hopefully that would be obvious if we were to write this out anyways, that we would need 2 on my potassiums. But I would be making potassium solid and iodine probably liquid, maybe solid, depending on the temperature there. And then I'd take my negative minus a negative to get an even more negative value. This would require a little bit more than 3 volts in our solutions. So we can look at things, but we're whether it's in water, a pure substance, or a mixture, but we're always looking at what can be reduced. It would be a cation or an aqueous solution, it'd be water. What can be oxidized, and that would either be our anion or in aqueous solution, it would also have the option of being water.